This is your white project paper. So somebody, number one, I want to point out that you must show your work on your graph paper, correct? And I want you to label what it is. So if they're asking for the slope of AB on your graph paper, you should say AB is what? And then show me what those numbers are. So -10 minus a negative, it's y over x, sorry. AB would be 7 minus 4 over a -10 minus a -4. Are we good? Okay, so I'm going to give you the answers, but more importantly than the answers, number one, if you don't have the right answer, we need to figure out what you're doing. But more importantly, I need you to start thinking correctly, because my job is not just to teach you how to solve a problem, but how to think about a problem. Okay, so right here, your answer should have been -1/2 and undefined. Now I'm going to tell you that some of you right here had -3/6. That's not wrong. It's just not reduced. So make sure that you reduce your answers. It's very important. Okay? Right here for these two, some of you had 10, some of you had 0, some of you had 10/0. Okay? And you thought that this one was wrong because it kept giving you an error in the computer or in the calculator, right? Okay, it's not 10. The length of it is 10, but the slope is steepness. Is it 0? No, a horizontal line has a 0 slope, right? Okay, so it's not 0, it's 10/0. It's going to give you an error in the calculator because the line looks like a vertical line. Can you drive a car up a tree? No, it's going to fall off. It's not possible. That's the slope right here. The slope is undefined. Okay? So what shape could it possibly be? Well, this is the part that we're not sure of. So I need to use this information to help me narrow it down. And you don't have, or you're not going to remember yet, right? And that's why I just wanted to get you to think. Why do you think it's a parallelogram? Could it be a square? Or a rectangle?
Yeah.
Or a rhombus?
Yeah.
A trapezoid?
No.
Why not?
But it doesn't look like one.
How do you know? Okay, but I'm not going by looks.
Oh.
I just want to look at the slopes. What? Let me ask this question. These two slopes right here. What do you notice about them? They're the same because they're going to be parallel. Well, what do you know about these two slopes? So I have two pair of parallel lines, right?
Yeah.
Well, automatically right now,
It can't be trapezoid.
we're getting rid of two. Why can't it be a trapezoid?
Because the side lines are not parallel.
Aha, remember a trapezoid is a triangle with the top cut off. So yes, these two lines are parallel, but are those two?
No.
No, so it's not a trapezoid. And then for a kite, this is a kite, right? Are these two lines parallel? No. Okay, I'm going to tell you right now on a kite, none of them are parallel. Okay, that's one of the properties we're going to be learning about. So right now, if I'm thinking about it, I'm going to say, well, okay, that means that this can be a rectangle, this could be a square, this could be a rhombus, whatever that is, and this could be that parallelogram, I guess. But I know for sure it's not a trapezoid or a kite because I have two pair of parallel lines. Are we okay? And those are the kind of characteristics I want you to start thinking about. Oh, well, wait a minute. I should also be able to eliminate two more. What does a square and a rectangle have in common? Their angles are what? 90 degrees. So if I have a square where the angles are 90 degrees, what do you know about these two lines? What would that be called? Perpendicular, right? What do you know about the slope of perpendicular lines? There's a letter. What word did I tell you to think about when you saw perpendicular? Opposite reciprocal. Very good. So are these opposite reciprocals? If this is -1/2, shouldn't this one be 2/1? It wasn't. It was 10/0. So are they 90 degrees? No. Okay, you didn't even know to think about that kind of stuff, did you? Okay, which is what this unit's about. I want you to start thinking along these lines. How do I know for sure? So now it's not a rectangle or a square. It's only a rhombus or a parallelogram. Mr. Ramsey, what in the world is a rhombus or a parallelogram? Right? Okay, so I kind of tricked you here because you don't really have these skills yet to know what they are. Would you agree? But you had the skills to break it down to know what it's not. Is that true? Okay. So, any ideas of what's the difference between a rhombus and a parallelogram? Anybody know anything about a rhombus? All the sides are the same. Oh, so what you mean is a rhombus is a crooked square. And a parallelogram is a crooked rectangle. Oh, so wait a minute. If my next venture is to find out the length of all the sides, if this is a rhombus, what do we know about these numbers? Oh, they'd all have to be the same, wouldn't they? Are they?
No.
No. So right here, you had the square root, I think, of 45. Is that right? And then down here, you had the square root of 100. I don't want to leave them as square roots. Change them to decimals. I want 2 decimal places. So this top 2 should be 6.71. And the bottom ones are just 10 because it's an even number. Are we okay? So what shape is this? It's a parallelogram. Now, I messed up. I forgot to make an edit to my worksheet. Will you please ever so forgive me?
Yes.
Okay, right here, we already know it's a parallelogram. That's what we narrowed it down to. Right? Right here, I want to know what are the 3 things. How do we know? How do we know? How do we know that it's a parallelogram? Well, go back up here to the top. What's the first thing we looked for? Parallel, right? So how many slopes were the same? So the first thing we looked for is we were looking for the same slope. And that told me how many I had pairs of parallel lines, right? And then what's the second thing we looked for? No, we were still up at slope. What do we look for when we were up at slope still? We looked for something. What was it? The what? What did we look for? Oh, why did I look for that again? See if they're perpendicular, see if the angles were 90 degrees. Okay? So the second thing I did is I looked to see if they were perpendicular, which means they're 90 degrees, right? I looked for the opposite reciprocals. And then the third thing was what? The sides. I looked for the length of the sides. Were they all the same or not? Okay. And that matters. What about a trapezoid? How many sides would a trapezoid have that would be the same? Oh, be careful. Hold on. If I have a trapezoid and I cut off the top, my question is, do these have to be the same? Would this one be the same as this one down here? No, not for sure. Small and big side, right? I'm going to warn you right here. What if my triangle looked like this? And I cut the top off. Is this side the same as this one? Is this one going to be the same as this one? So all 4 of them could be different. Well, if all 4 of them are different, I know for sure it's not a square or a rectangle, which means it's not a rhombus or a parallelogram. Right? You with me? Which also means it's not a kite. So the only shape it could be is going to be a trapezoid. Are we good? Do you see where we're going? At some point in time, I'm going to say, oh, here's the diagonals. What shape could it be if you know this about the diagonals? Ooh. Have you even learned anything about diagonals yet? You haven't, have you? So, this is what you thought this whole class was going to be about. All these shapes and stuff, didn't you? But I had to teach you all this midpoint and length and slope stuff to help you relay, to help you know more information about these shapes.
Can't a square be a parallelogram?
What a great question that is. We'll learn that in the next couple of days.
Very smart.
I know, isn't she? And the question was, isn't a square a parallelogram?
Yeah.
Well, is a square crooked? Does it have to be?
No.
So that's one of the things we're trying to get to. You already have that, oh, a square is a rectangle, or a rectangle is a square. Have you heard that before? And how many of you just get confused every time somebody says that? Not even paying attention. I got it. I got it. All right, so let's look at the top of this other side over here. Okay, now it wants us to talk about diagonals. We're looking at those diagonals. What's the slope of the diagonals? You should have had negative 13 over 6 and 7 over 6. Well, I don't remember exactly what your shape looked like, but it was something like this, right? Let me ask a question. If this is one of my diagonals, and this is my other diagonal, do I want them to be the same? Do I want the slopes to be the same? Because if I have the same slope, what do you know about those lines? They would be what? Parallel. Are those lines parallel?
No.
No. Good. This question is being asked because I want to know on what shapes should a diagonal ever be parallel?
No.
No. I never want my slopes to be parallel. On what shapes are they going to be perpendicular? Are they going to make 90 degrees? Because eventually I'm going to say, these diagonals are perpendicular. What shapes could it be? And I want, well, I don't know. Is it a rectangle? Are you for sure? That's why we're doing these worksheets to see which one comes out to where they are opposite reciprocals. Okay? This is negative 13. If I switch it and change it, it's not perpendicular either. This one is going to be your neither. So if I ever ask you if your slopes for your diagonals are perpendicular, is it going to be a parallelogram? No. Nope. Okay, what's the length? This one, I believe, is the square root of 205, which I believe is 14.32. And then this one would be the square root of 85, which is 9.22. Okay, do I want them to be the same or not? Are they the same? No, they're not congruent. Are they? Well, look here at this shape. Okay, what shape do I have?
Square.
A rectangle, because my colors are different, right? Okay, I'm going to put my diagonals in there. Okay, I know they're not long enough. It's okay. But are they off the same amount? Right? Like I'm missing this much? Am I missing that same amount right here?
Yeah.
So what do you know about your diagonals?
Congruent.
They're congruent. But we're talking about a parallelogram. What's a parallelogram? It's a what? It's a crooked rectangle, right? Did I just make this rectangle crooked? Now look at this diagonal right here. Compared to this one right here. Are they the same? Do we want them to be the same? So if we're talking about a rectangle, then I want these numbers to be the same. But if we're talking about a parallelogram, do I? One has to be bigger because they're slanted. Does that make sense? One of those diagonals is absolutely going to be longer. All right, and the last one, part of the hardest one, what are the midpoints of the diagonals? You should have had negative 7 and 10.5 for both of them. What does that mean? That was the hardest one. Yes, they're the same. But what does that mean? A lot of you just sat there and were like, I don't know. Okay, well, let me give you an example. If I have a parallelogram, let me write it like your shape. Right? Is this diagonal the same length as this one right here? On a parallelogram, are those diagonals the same length? No, one's longer than the other one. So if the green one was 10 units, and I found the midpoint of it, then each side would be 5, correct? If the blue one were 20 units, and I found the midpoint, then each one would be 10, correct? Are you with me? So let's look at this shape right here. Are my diagonals going to be the same length? No. Okay, so if I found the midpoint of the green one, it would be right here. Is that where the midpoint of the red one would be also? No. The midpoint of the red one is going to be right here. So do those diagonals bisect at the same spot? Do they cut each other in half? The red one cuts the green one in half, but the green one does not cut the red one in half. Are you with me? So when they do this and they meet at the same point, what it means is that they bisect each other. What does bisect mean? Cuts in half? Does it mean that they're the same? Are all of these the same? No, I have a 5s and I have 10s, right? Doesn't mean they're the same, it just means it cuts